Okay, so let's start by looking at the naming conventions in geometry. So a single dot represents a point, like the point P or the point A and so on. A line with 2 points on it, A and B, is the line AB. So AB is a line. If I take 2 points and connect the 2 points and 1 point is A and 1 is B, that's the line segment AB with the square brackets. If I take 2 points A and B and I join the 2 points with a straight line that carries on through, that's known as the ray AB, and that's signified with one square bracket and no square bracket where the ray shoots through. And if I see a symbol like this where I have AB in between the two straight lines that surround A and B refer to the size of or the length of AB. So if we see here, we have the size of AB is equal to 5 centimeters. It gives us the length of AB or the size of AB, and we say the size of because we can use this symbol when we're referring to the size of an angle, which will come to equals, say, 30 degrees or something. Okay. So let's look at angles, and we'll just remember that angles are measured in degrees, and that's the symbol for degrees. And basically, when we're talking about angles, we're talking about if we have a straight line AB and we rotate AB up to another position, this generates or creates an angle in here. Okay, and the size of an angle depends on how much we rotate the lines or the lines they're attached to. And a full rotation gives us 360 degrees. So if we start here and we rotate a line all the way about itself back to where it began, we've actually rotated through 360 degrees. If we go through half a rotation, that's 180 degrees, and a quarter of a rotation is 90 degrees. So let's look at naming angles. Let's say we have a line OB. We have a line OB, and that's joined at O to a line OA, and between the lines OA and OB we have an angle. How do we name that angle? Well, there's 3 ways we can name the angle. The first way is to refer to the vertex of the angle where the 2 lines meet. Refer to that in the middle of our name convention. We use this angle symbol here, and we say that this angle is the angle AOB. So we know that the angle is actually at position O. Or we can also say that this angle is the angle BOA. So it's this middle letter tells us where the angle is sited. Or we could just simply use a third way where we refer to the angle as being the angle at O, which is here. It's a simpler way, third way. So similarly, we have DE joined to EF at E, and that creates an angle here that's known as the angle DEF, or the angle E, or the angle FED. Let's look at types of angles. So a right angle is derived when we have 2 lines that are perpendicular to each other or are at 90 degrees to each other. And the symbol for a right angle is that symbol here. We have a straight angle, which is 180 degrees. We have angles that are acute, in that they're less than 90 degrees. If they're between 90 and 180 degrees, they're known as obtuse. So this angle here is between 90 and 180. Or if we have angles that are more than 180 degrees, like this angle here, they're known as reflex angles. And often the other angle is known as the ordinary angle if it's less than 180 degrees. So an important rule of geometry, the first rule we're going to meet, is that angles on a straight line add up to 180 degrees. So I have a straight line here, and I have an angle that goes all the way around, that's 180 degrees. And the angle B plus the angle A equals 180 degrees. Or here I have a straight line, and I might have two other lines meeting that straight line, which dissect this whole angle of 180 degrees into A, B and C. But we know from geometry, we're saying now, that the important rule is that the angle A plus B plus C is equal to 180 degrees. And again, we have a straight line angle of 180 degrees here, dissected by this line, generating an angle A and an angle B. The angle A plus the angle B is equal to 180 degrees. And so let's look at an example using that rule, or working with that rule, that the sum of angles of a straight angle is equal to 180 degrees. So we have a straight line here, so we have a straight line angle of 180, but that's dissected by this line and this line, which are at 90 degrees to each other. So we can say that this angle B must be equal to 180 minus 45 plus 90. Or here we're saying that B plus 90 plus 45, this plus this plus this, B plus 90 plus 45 is equal to 180. So B must be equal to 45. Because if I add 45 and 90 and 45 again, I'll get 180. More complex one here, we have a straight line angle. It's all worth 180, but it's dissected by this line here, which is at 90 degrees. So if this is 90 degrees, the whole angle is 180. This 3x must be equal to 90 degrees as well. We have that here. So x must be 30. And again here we have a 180 degree straight line angle, but it's dissected into three parts here by these two lines. Generates three angles of 60, 2x and x. So the best way to solve this is to say, okay, 60 plus 2x plus x must all equal 180. So 60 plus 3x equals 180. 3x must be equal to 180 minus 60. Bring over the minus 60 here, which is 120. So x must be equal to 40. Now we'll look at a second important rule, and that rule is that angles at a point add up to 360 degrees. So if I have a point and I've different lines radiating from that point, then the angles that are generated in between those lines all add up to 360 degrees. So for example, I have here three lines, three angles, 140, 140 and B. If I'm to find B, B is 360 minus 140 plus 140 is 280, B is equal to 80. And again here, I have three lines. This is at 90 degrees, this line. This is 130 degrees, and we've C. So C must be equal to 360 minus 90 plus 130, which is 220. C is equal to 140 degrees. And now we look at a third very important rule, and that rule is that vertically opposite angles are equal. So if I have two lines that crisscross, the angle here, A, is equal to the angle B, and that's denoted here. Or two lines that crisscross, the angle C is equal to the angle D. Vertically opposite angles are equal. So look at this example here. We have two lines. We're given one angle of 40, and we've with the angle C, D and E to find. Okay, so there's two ways of doing this. The first way is just to work what I say, work the straight line rule. Okay, so you can look at your problem and then you can just focus on this line here. Okay, and you know that that's all 180. If that's 40, this must be 140. Okay, and then you can say, okay, if that one is 140 and all that's 180, C must be equal to 40. And then if C is 40, you work that way and you see 40 from 180 gives you D, which is 140. One way of doing it. Another way is just to use the vertically opposite rule. So if this is 40, this must be 40 also. And then you can say, well, if that's 40, from 180, that must be 140, and if this is 140, this is vertically opposite, that's 140 as well.